Now it's my turn as the last speaker, at least here in front of the audience, and then we'll have still quite some time for discussion. My name is Martin Scheringer, and I'm here as the president of the board of the Food Packaging Forum Foundation. This is the full name because the FPF is actually a foundation, and there's a board that oversees the work of the foundation and makes sure that the FPF works in accordance with the mission or the mandate. In my normal job as a scientist, I work at the Swiss Federal Institute of Technology at ETH, and I work in the field of chemical risk assessment, environmental chemistry, and exposure assessment for the environment mainly. So first of all, I would really like to sincerely thank all speakers. It has been a very productive day. The talks have all been really great and excellent and inspiring. And my first thank is really to you as the speakers. I find it also fascinating to see how the talks really fit well together to form a big picture. That was something that we couldn't really plan, but I think it has happened, and that's really a great experience. Then I would like to thank all of you because it has been a long day, a demanding day. The format of the workshop was really packed. But this was, as Jane already said at the beginning, this was on purpose. We wanted to use these many different perspectives and learn as much as we can about the TTC concept. So it was really on purpose, and we thank all of you that you were willing to join us in this experiment. Then my next point is I will now try to summarize my impressions. Of course, this is subjective, so I apologize if I misrepresent any of the ideas or intentions of any of the speakers. I will try to identify some questions for further thinking and also starting points for discussion. But I think we will have enough food for thought anyway for the discussion, and so I'm not concerned that we will have a very active discussion after my summary here. Okay, so first, I have learned a lot. I'm not an expert in the TTC field. In my first few slides, I would like to summarize my impressions from Jane's talk and the talks by Susan Barlow and Alexandra Feigenbaum about the history of the concept and the current application, let's say, or applications in the field of food contact materials. So we have seen it has been a long history. The development of the concept has taken several decades, from early beginnings in the 50s with first testing results, and then the really important work by Kramer et al. And Munder et al., and then even in recent years. I think it's important to keep in mind what is the factual basis of the concept. We have learned a lot, thank you again for your talk, Susan, about the underlying reasoning, how the classes were defined, the decision rules, and then, of course, a key question was how conservative is the tool, or that was kind of the way to put this. It was also good to learn that there are tools that users can download and use. So there's ToxTree, and Gerrit Schürmann told me, and that's what I also know from our joint work as part of the OSIRIS project. This was an integrated EU project on risk assessment methods, non-testing methods. There is a tool called ChemProp that's provided by the UFZ in Leipzig, which is also available and also has or contains or includes an implementation of the decision rules for the Kramer classes. And this is also free of charge. Then we learned something about the current applications in the field of food contact materials in the EU. From Alexandra's talk, this was also very good to see. So the concept is used always in combination with data. It's not just a standalone thing. So there's always context, and this is data and also a strategy. We also learned important points about limitations. So there were these different exclusion categories, and that's then something that will lead to Gerrit's results and insights. Of course, there are many chemicals or types of chemicals that are not covered or not represented in the initial set of the 613 chemicals. And it's important to, from the very beginning, identify chemicals that should not be treated by the concept. Two important things that will, I guess, cause more discussion are mixtures, and a specific type of mixture is NIAS. We heard kind of slightly diverging interpretations of the situation with NIAS. You explained that it may be used, but it has not been used, so which is still kind of consistent with what you said. And again, the question was, how conservative is the concept? This was the last part of Alexander's talk. Very important question. How can we estimate the percentage, estimate the risk of being wrong here? And I think this is still, to me, this is still an open question. This is my attempt to summarize the next group of talks, which is Gerrit Schumann's talk about applicability domain, and Chris Tolsness's talk about the data here in the middle, the actual talks data, and also Olwen Martin's talk and Pete Meyer's talk about extrapolation factors and what can we really say about the likelihood of actual effects. First, I think this green little domain should be even much smaller because it represents only I'm the first speaker who may cause this kind of pushback. Yeah. And perhaps it's just also an indication that people are getting tired and it has been a long day. Anyway, so this green field should be smaller because it's only a small fraction of all the many chemicals on the market. Gerrit talked about the 70,000 chemicals approximately that are listed in ANIX, which is the European inventory of so-called existing substances. Importantly, I think that's an important aspect also for the domain considerations that Gerrit presented. There are many, but they don't contain the specific structures of plant protection products and pharmaceuticals, neither hormones. Then there was the question about what are these data? What do they really represent? How good are they? And what I understood were the questions from the early testing. This had this strong focus on hazard. So is it really good dose-response data that we can obtain from these tests? And also important life stages of the test organisms were not covered, so important endpoints might not be represented by these early data. Another problem is that from many of the earlier works, the raw data are not accessible, so we cannot recalculate, for example, the NOAEL and the statistics of the data. Then Olwen talked about the extrapolation factor. I will come back to this in a minute. First, go back to Gerrit's work. If I understood you correctly, the good news is that the TTC, as it is defined, can be applied to the majority of these 70,000 chemicals. There is this domain here in red, which is about 1/3 that are outside the domain, but the others are more or less inside the domain, and the concept can be applied.
Our suggestion is
if your calculation of the domain is good. So that's good news. Thank you for this important point. Then, as a scientist, to my mind, what came to my mind was then this point here concerning the data. What would happen if we re-evaluated the individual data points, if we perhaps removed some of the data points from the set and then recalculated the 5th percentile of the NOAEL distributions? Because that's what the scientists would do. You would critically evaluate the data, eliminate the ones that you don't think are reliable, and redo the exercise. Then here, there is the question of if the factor of 100 is appropriate, or if we should use something X, which is more than 100. Also, Pete talked about the question of low dose effects and how can we, if at all, extrapolate to these low levels. Then there was Thomas with the talk about the mixtures, and these are serious problems that we have known for quite a while, because they are the same problems also in conventional, detailed, data-based risk assessment. When we have more chemicals, we will have to lower the TTC value. And we'll have to face difficult questions. We have to identify the relevant components of the mixture. We have to determine the number, the N you used, and we have to estimate the concentrations of these components of the relevant components of the mixture. As I said, this is a problem that has been discussed for long and is also one of the serious questions and problems in conventional data-based risk assessment. One question, one bullet point concerning Claudia Heppner's talk about EFSA's work and how EFSA assesses chemicals or food contact materials. For us, I guess, and from a scientific point of view, it will be very interesting to learn what the revised guidelines will contain, because these assumptions, I mean, there are many important assumptions that are made in the exposure assessment, and it will be important to, let's say, scrutinize them and find out, what kind of exposure, what kind of result for the exposure we obtain from these, based on these assumptions. Then, this is my last slide already. So to me, the key questions really were, what are the chemical structures that can be covered by the concept? So what is the applicability domain? And at the same level, how reliable are the toxicity data that are used? If we revise the set of toxicity data with more new data, we would have also to perhaps revise the applicability domain considerations, because other structures might be represented in the set. Then the question of mixtures, the question of low dose effects. And then something that Xenia Tree and I discussed last night extensively, because we have to make, this is also linked to your talk, to make decisions under uncertainty. And the key point is, even if we don't have tox data, we know something. We know the chemicals are there. They're present somehow in the materials. So if we don't do anything, we would assume the chemicals are not there. So, or in other words, or conversely, there is a real need, or we have to represent the chemicals that are there, but have not been tested. We have to represent them in the assessment. We have to find a way, and if it's just a concept that can be used as a placeholder, but if we don't represent them at all, this is equivalent to the assumption that the chemicals are not there. That's my last word, and I hope this is a thought starter for the discussion. Thank you for your attention.